All right, good morning or good afternoon, everybody. This is Zach Parnell with ITI. I also have Caitlin Lowry in the room with me. She's a marketing associate with ITI as well. And oddly enough, we are in Washington State. I know that we're going to kind of go over where you all are, but Mike Parnell, the presenter today, he's in New York. He's actually just told me he was at a legal office. So I'm hoping that nobody comes in the room and annoys him with anything. So we're going to get started here, though. So it's about 10 a.m. Pacific time, 1 o'clock. This is the Lift Planning Considerations webinar. And if a lot of you, I've noticed, thank you for all rejoining us. We've been doing this showcase webinar series for a few months now, and it's basically a monthly webinar series. But if you don't know much about ITI, we are a crane and rigging training and consulting company. We really pride ourselves in skills building, training, and education. Not so much after we do certification training as well, but we really are focused on advanced rigging and lifting applications and inspections. So we have a lot of friends and customers on the phone, as well as visitors and other people, and we just really appreciate your time. To give you a little more background, we have a pretty vast variety of industry groups that we serve. As you all know, I mean, just looking at the companies in attendance here, which I'm going to go over, it's pretty incredible the amount of activities or industries that conduct crane and rigging activities, as you all know. So to give you an idea, for instance, on the phone, I think right now there's about 22 countries represented. There's over 230 registrants. So you're all in a big group together, whether you know it or not. But I'm going to show you about a social infrastructure we have after the webinar that you can communicate and get to know each other a little bit. But there's also 48 U.S. states and Canadian provinces represented, and then along with a lot of the folks you see here on the companies you see here on the screen. On the phone right now is Alstom Wind and Power, BAE Systems, Siemens, Shaw Group, Crosby Group, ThyssenKrupp, U.S. Army Corps of Engineers, URS Corp, Vestas, Disney, DuPont, U.S. Navy, Kiewit, Fluor, Entergy, Duke Energy, BP, GE Energy, Manitowoc, Mitsubishi, and dozens more. So we really appreciate your guys' attendance, and know that we really do this to kind of give back and to give people a kind of an idea about ITI. And if you haven't been to some of the previous webinars, you might go check those out. There's several recordings on the webinar or the showcase webpage. It's iti.com/showcase. These 4 are obviously up there. And you can also download the presentations, which is pretty neat. So not a lot of folks are able to attend live, so they go register and then download it and watch it afterwards. So today, like we said, we're doing lift planning considerations. A month from now, I'm going to give you a little background about Mike as well, but he's going to do a presentation on the ASME B30 and P30 developments. I saw a lot of you folks had some pre-webinar questions about P30, actually, because this is obviously on lift planning. So the next presentation, you won't want to miss that, September 7th, okay? But to give you a little background about Mike Parnell, this is also Dad. I try and fool people that, you know, we're brothers sometimes, and he loves it, and but I don't know if anyone's bought into it yet, but he's a strikingly handsome man, and no, he's got a lot of experience in our industry. He's ASME B30 Vice Chairman and P30 Main Committee Chairman. And these committees, I mean, it's all volunteer. There's a lot of great people that he'll probably reflect on in this presentation that commit time and energy to developing really world-leading standards adopted in obviously many countries around the world, U.S. and Canada especially. So a lot of people, he heads up our organization, and we have about a dozen trainers that conduct services around the world. But without further ado, I'm going to kind of pass over to him as we can get started. And he's going to go over the agenda and some other things here. And I just want to preface you guys, if we have any technical difficulties, please forgive us. It's just that we've had a few in the past, but we've always been able to get through them. But that's just technology, isn't it? So again, I'm passing it over to Mike, and you should be seeing his screen now. So take it away, Dad.
All right. Well, great. Thanks for everyone for joining us today. And Zach, you see my screen up, Zach? We have a whole series of program activities that we'll be discussing. I would like to thank Jim Richardson of the Navy Crane Center has joined us today. Jim is also on the B-30 main committee and heads up the container crane group on B-30.24 and has been a long-term member and really thankful he's joining us today. Carl Johnson is with BP out of Texas. Carl works with me on P-30 on the lift planning group, and we have a whole host of, as Zach has mentioned, companies that have joined us, and we're looking forward to a pretty good fast-paced series here. I think one thing I want to caution everybody about is in our discussions, we will be giving a P-30 update, and I do want to bring out that what you're going to get involved with me today on this discussion is in some part about the P-30 development, and there are about 20 people that are on that group, as well as another 15 or so that are contributing members. And the P-30 group has been meeting for about 2 years now, and we're hoping to get some good conclusion to our work for lift planning in about first quarter of 2013, and we'll be able to start getting a document out to the general industry. And some of these efforts that you're going to be seeing are sort of a roundtable discussions and general directions of where P-30 is headed, as well as where ITI thinks we should be going in preparation for standard lifting activity and critical lifting activity. So I really want to give a lot of credit to my brothers in arms, you might say, for the brainstorming that's gone forward. I don't think any of this is secret information. We're and or in some cases always original, but it is a format and a layout that might be new to a lot of folks. In some part, we're going to each organization in our today's agenda will be looking at forming a decision tree of some type and considering conditions and consequences. And then we'll be discussing quickly the difference that we might identify between standard lifts and critical lifts. And of course, there's some concern about verbal versus written plans and then managing your risk. So we're going to charge forward. If you have questions, type those in and into your question box there, and Zach will help me deal with the questions at the end of the program. And so we'll get those cleaned up towards the end. So let's start on planning requirements. We had started, there's been much discussion about having 3 primary categories initially in a lot of the national discussions we've been involved with, and those were under either production or what we call repetitive lifts, and then standard lifts, and then critical lifts. And pretty soon it got clear to all of us that really these are the 2 primary, standard lifts and critical lifts, because you can then also have within the standard lifting family, you can end up with repetitive lifts in the standard lift group. So what we've done is, the suggestion is, in the standard lift category, it will have a subset of repetitive standard lifts. And very closely to that, and it may sound odd to us sitting here today, but critical lifts, and it may be in a nuclear environment or shipyard shipbuilding where it may be a 92% lift, but you have to make 6 identical lifts, one after the other. So we've also included under the critical lift group a repetitive category, or repetitive attention being paid to even critical lift activities. So that's kind of how the discussions flowed so far, and I think that's the travel path. And so each organization, in effect, will be making up and they do already make up some decision tree. So we have a load handling activity. You'll see some new verbiage coming out in our industry pretty soon. LHA, LHE is load handling equipment, lift director, and so on. So we have identified a load handling activity, and we'll go through a series of criteria that we're going to see this morning. and then the organization. So here's criteria, and the organization may end up deciding if that's a standard lift or a critical lift. And so it all kind of gets down to what's the risk involved in some of the criteria that we're about to discuss. The equipment that we're really talking about that will be in some of the standard coming up in the future, as well as in our current sphere of operations, because this can go from the wind energy group, our industry, to shipyard, ship repair, can go to mining, nuclear plants, refineries, all kinds of facilities, and indoors and outdoors, underground, horizontal work, all kinds of things. So the typical equipment that we're really dealing with, and I'd say in a large part is going to be really dealing with cranes, mobile cranes in many cases, telescopic gantry systems, winches, strain jacks for large lifts where a crane can't get in place, but strain jacks can lift the vessel up and work. May involve helicopters, rotorcraft, and it is all about vertical and horizontal work, and critical. And when we say the word lift, I do want to kind of get us into a mindset. When we use the word lift in all of our future discussions, I do want us to be thinking about not only vertical lifting, but also horizontal work. So the word itself, I know it's a stretch, but it gets the idea. Because a lift director that's involved in a winching operation that's taking a load in sideways through a building, he's really, it still carries the connotation that we actually likely have to jack that thing up, put it on rollers or air casters, move that load in, airbag the thing down, and or jack it down. And so lifting really, there is some lifting activity involved, but it's don't get too wrapped around the axle about lift, because it really will be involving vertical and horizontal activities. Let's take a look at some of the things we probably would exclude from some planning activities, because a lot of these types of equipment may not have, you have to ask your question, do these other kinds of equipment really have the design factor that we're really looking for within that equipment? Is it built for the type of handling activity that we're looking for? In some cases, does it have a redundant system in it? Maybe multiple braking systems, et cetera. So there's almost always going to be an exclusions list that we wouldn't want to be producing for what we'll call load handling activities that aren't to dedicated equipment. So we kind of look at an automotive jack or a portable automotive lift system, PAL. Those likely fall out of the standard lift and critical lift family, because they're dedicated to specific type work activity, and they have specific manufacturer's instructions about capacity, setup, inspection, operation, and the only thing we're really supposed to be using those for are a specific set of load types in a restricted environment. So you'll always see an exclusions list. Wrecking operations can be kind of Katie bar the door. We have all kinds of inclines and hazardous conditions, road activities. Doesn't mean it doesn't take planning, but in a lift planning document, in our environment, it really is going to work under the approved. And I guess I could drive you back to some of the best listing will be to see the equipment that's listed in the B30 series for load handling machinery and equipment. So most of the time, these wreckers come out of that. Shipboard cranes, because they're not typically under the B30 family, and so it's really ship deck cranes, et cetera, but we will find portal cranes on dockside, or barge-mounted cranes, floating cranes. We certainly have those within the B30 family, but shipboard cranes on freighters and things will typically be outside of it. However, there may be times when heavy haul ships are moving transformers and other equipment, and the lift planning process will be incorporated into those for your particular activity. Well drilling rigs, skip hoists, those are typically very dedicated to a specific task, and those will be outside of this little agenda. The balance of the list you can see as well: mine hoists and truck hoists, barge pullers, conveying systems or dedicated systems, excavators. Almost always dirt moving equipment is outside of the standard lift, critical lift family because of we're lifting unspecified amounts of weight in unspecified volumes in some cases, and so the control method is very difficult. So we really kind of work our way away from using excavating equipment for load handling for standard and critical lift. So in any other non-B30 equipment, as I stated before, that's probably our biggest target is the B30 type equipment. Here's a new phrase. As I've introduced in a few webinars in the past, you're going to see some new acronyms over time. And throughout this entire, in the proposal and the thinking coming forward with a number of folks within these lift planning documents, you'll see this phrase LHE, and load handling equipment will be that first list that we offered up with cranes, telescopic hydraulic gantry systems, strand jacks. And so all of those things will be under, as called out within the volume downstream. Our current thinking is those will all be termed LHEs, and as applicable to your environment, that will mean a crane, a mobile crane, a tower crane, an overhead crane, a gantry crane, and so on. And when using that crane, these are the guidelines to follow. So here's a new phrase in front of us that we'll be seeing quite a bit of, I think, across the industry, and as it starts to enter into other documents. We have also a new term, lift director, of course. We've seen this term pop up in the ASME B30.5, and it was in the 2007 revision, and now we have a 2011 revision out on the street. But they identified 5 key players, and which we've had some discussion on and part and parcel in previous webinars, and that was lift director. And for their case, it was crane operator, crane owner, crane user, and site supervisor. Those are the 5 primary folks that they identified early on. And of course, in a lot of these elements, we've talked about lift directors. The new OSHA document mentions lift directors in a few areas. So if you want to take a look at the 29 CFR 1926.1400 document, do a word search through there, and you'll find lift director. If the lift director is being used or named, and in a few cases, they do call out the exact or a recommended purpose for lift director, and it is something that's going to hit the airwaves, I think, bigger throughout all of our industry and all the things we're doing. So let's take a look, and this is really a good place too. It's one of those things that the lift director. Let me start it this way. Lift director is a qualified person to be able to perform numerous tasks that have to do with, and I'm going to suggest to you, he really needs to understand the LHE activity, the rigging of the load or load handling activity, and then all of the safety elements, personnel management of the team, and the procedures. So he really needs to have a very large 30,000-foot view of what's going on and what is going to be about to be tasked. However, I think it's through some advisement with some of the folks that we've been working with in our industry, they're not really always the final say as that, is this categorized as a critical lift? They're a great resource person, but I want to be cautious about putting too much on the lift director's shoulders because he's really a doer. And this is one of the things I'd like for you to take heart with, is that on the advisement of management, and management will end up with a risk tree, and they may decide that based on a matrix, they're going to decide if we hit 3 of these points, and based on their insurance and liability, they may say, well, and this 4th one down here, okay, now it's going to be a critical lift, and we're going to need the lift director to get involved, and he's helped make some of that decision for them. But I want you to get the idea that it's not all riding in the hip pocket of the lift director to make that individual call every time. We really want to make sure that management is deeply involved in the decision process and who've been tasked to protect the corporation, its shareholders, and its equipment and its assets. And they will likely, as a group, be involved in deciding standard lift category and critical lift category. The the lift director in particular will want to be able to identify the skill level of the personnel involved and also the adequacy of the equipment. Is it okay or not okay? Are we using the best machinery here for this lift or an acceptable piece of machinery? He may end up with creating an options list that instead of using a 550-ton mobile crane, he may opt to come back to management. We'd really rather invest a little more money here because it's safer to put in a telescopic hydraulic gantry system. So his job is to know all about different LHEs, and he may end up with proposing back to the organization, we may be using the wrong tool for the wrong job here. Let's put another type of machinery in, and it'll maybe save us some money, but certainly potentially save us some time, and most importantly, probably drive the risk down and increase the safety part of it. He may be involved in the dollar cost estimations. Then this has to do then also with the load for replacement time. He could be handling a load that is maybe has a 1-year replacement time, and that certainly can push us into a critical lift category. Management's going to decide, gee, because of that, we will assemble ourselves. We're going to probably need an 8 to 10 person planning team at least for a short time period before we get everything off the ground and get the planning phase in full motion. But the replacement time may drive this critical lift development. Percent of lift is going to be a decision some folks will make. I know that in some of your organizations and numerous clients, some folks work on something of an arbitrary 70% value, 75, 85, up to 95 or better, and decide at a certain percentage we will require a critical lift plan to be developed. Also, you'll notice if we're going to use multiple LHEs, that's a 2-crane pick or 3 or 4 crane. I just noticed we had a good client that had an 11-crane pick the other day, and a lot of dependence on the load moment indicators to make sure everybody stays within capacity. And certainly when we get down to hoisting personnel, that would be almost on everybody's list. Lift director would jump up and say, absolutely, we need a critical lift plan. It could be a 1-pager. It doesn't have to be an exhaustive, massive list or a planning document. But when we start lifting people, we really need to have our ducks in a row. We are still, in some cases, finding folks that are getting injured around our job sites and workplaces, and by lifting them in man baskets and so on. So lift plan documents are very important, and somebody to drive that is really the lift director. He's really the go-to person to kind of make all that happen. Zach, I think we've got a polling question here I'd like to have, if you can put that up on the screen.
Yep, it's on the screen now, and the question, everyone, is where does your company stand on the use of a lift director? Go ahead and you can select one of the answers now. It's have not started, just started, have used a lift director for 1 to 3 years, have used a lift director for 3+ years. So we'll keep it open for a few seconds. And Mike, while we're waiting, there was a question that came in from Brant Peters from SuperSling that's pretty good while I have the mic, is what determines the lift director being qualified? You mentioned that he has to be qualified. Is it by his experience, or does he need to be an engineer?
Right, good question. And the lift director, needs to be a qualified person, of course, as we stated before, and that qualified person can get that by experience, by training, by knowledge, and by performance. And it really is going to be up to the employer to make that determination. And it could be a person that has a certificate or degree in the associated work, and that may also play a role in it. But it will be, I will say it's the employer's choice, employer's decision as to identifying their qualified persons in any category. And and I would put that five-item list as at least the core base, or certainly maybe other items to that. But the employer really is going to need to identify who are lift directors, and based on, and really name them by name in the organization. That can be done. I know we have had lift director training for 5 years that I know of, and then critical lift planning additionally. But the employer wants to identify a number of folks in the organization as qualified lift directors, qualified crane operators, qualified riggers, qualified signal persons. It's all driving that way, and we see big certification programs, of course, afoot, helping do that, and so on. So, but the employer, I got to tell you, Brant, it's a good question. The employer is actually making the final decision, and if somebody walks in with a certified lift director card, it's really the employer's decision is to evaluate the background of that card and how that certification was issued, because most likely it's going to have to be tied to that in that case would be a certification degree. You may want to look at his training background, what his real experience is based on resume, and then what his knowledge is, which can be done by personal interview and action, and then what his performance in the field is. So very good question. Yeah. I will say ASME has taken this entire tack, as well as OSHA, is it's going to get back to the employer's decision tree. So if that helps your question.
Yeah,
okay?
I think that answered it well. And just so you guys can see the we have both ends of the spectrum here represented. It looks like about 1 in 3 folks said that they have used lift director for 3+ years. About 40% have said they haven't started, and then it's 10 to 20% between. So
okay.
Very interesting results. We'll pass it back over to Mike.
Awesome. All right. Well, there's movement afoot, lots of movement afoot, and we're all moving in a good direction. We really need folks that have knowledge. They do accept the accountability, but it's all based on a management decision as to how we get there and why we're going to write specific plans. Here's some of the consideration points, and this is starting off our considerations list that I told you was in the agenda. And as we mentioned a few minutes ago, so this is our considerations point, and it's all about, and so management, as they look at this list, as well as the lift director, everybody's kind of putting these into a basket of, yes, this is an automatic for us, or no, this is maybe when coupled with something else, this falls into the critical lift plan family, or so on, or it stays in our standard lift category no matter what else happens. So our friends in our industry are going to make some of these decisions, but almost everybody would say, at least when we're transporting folks with an LHE of some type, that's going to call for some critical lift plan, and we would highly recommend that. I think all the folks that I've met around the table with in the last 2 years would certainly stand on that as a good, strong advisement. Then it gets down to a little bit of how's management and how's local site supervision feel about their risk level and comfort level when we have folks that are in significant hazard potential. And that might be somebody that's down in a hole, and they've got to work and make a connection. We're about to lower a big object down here and place it, and we've got to mount it up on a bolt pattern, and at some point we've got to access that to get it placed and landed. And so it may be that load goes down inside of that chamber, and at a certain point, maybe 1 foot off the base, we have a ladder access, and then we send an employee down to make that last connection. So he is in a potential hazard area. Many times you just have to go do the work, and sometimes somebody's going to have to be in a bite, somebody's going to have to be in that area to make that connection and jump, and deciding when do we consider that to be a critical lift activity, or is it standard lift because we do it all the time. The main thing there obviously is we don't want to give a swing motion with that crane or boom up and down to send that load crushing into the wall and potentially injuring that person. So that's what we kind of call, when folks are in hazard potential, that's when they really don't have any running room. And that's going to get down to the organization's decision as to, yes, we're going to call that critical lift in those particular categories, or no, that's standard lift with these special provisions, no swing, no boom up and down, and or radio communications, relay, et cetera. So that'll be everybody's decision as to when that falls into their lap. Folks in the fall zone, that's pretty common. That's going to be generally a standard lift activity. We don't want that we don't want the general public obviously in a fall zone of load, but it's almost impossible, and OSHA does and ASME does allow for assigned personnel, which is, let's say, is a rigger, 1 or 2 riggers and a signal person that's assisting with that, to be in the fall zone while the load is into its final placement. We don't want people under the load particularly under the footprint of the load. But OSHA kind of, and a lot of folks have this decision, well, what is the fall zone? And it's typically the area immediately under the load. I know other folks will paint some lines out like that and decide, well, that starts to get you well outside the workplace and the work area, and I don't really agree with trying to get this cone, safety cone, underneath the load, because you just, with an 80-foot load 80 foot up in the air, you're going to cone this thing clear out 300-foot perimeter. So it really doesn't make sense. It's really that area right underneath the load where somebody can, if we have a brake failure, if we have a hoist line fail for some reason, all kinds of things can go bad and wrong. But we end up with, this is the most risky, the most highest risk point right here. And if somebody has to reach in there to do something, maybe that's the time to lower the load down, put some blocking down to support that load or to rest that load in, make your connection, then get out of the way and remove the blocking and so on. So there may be provisions. How do we deal with folks in the fall zone of the load? Construction's very typical. We'll fly loads over and beams over folks. And it's just avoiding that long-term hanging part. It's sometimes a passover is going to be happening no matter what we do. You just can't get people out of the way, but they need to be hopefully assigned to the rigging task and to the crane activity. Personnel hazards that get considered also certainly would be for things that are suspended or swung over the general public. Quite often this will be likely in the critical lift category, not in the standard lift category. And that will be up to management's decision. It certainly happens a lot I'm downtown New York today, and lots of tower cranes up and taking loads off of street level and taking them up 20 stories, 30, 60 stories. But they'll have a landing zone or a work zone that's completely barricaded off. The truck pulls into it, and then we pick that load straight off of that, and this entire area is completely coned off so that flight, vertical elevation, then is taken over the building, then is cordoned off so the general public isn't really over that or underneath that load while it's flying. So some of those considerations have to be made, and we're looking to try to reduce the risk to the general public and certainly to the employees as possible. So loads containing hazardous materials, and that might be chlorine. It could be we've got folks that work in chemical plants, ammonia, sulfuric acid, all kinds of things. A lot of times you'll hear folks that will have a particular critical lift plan precautions for things that are liquids versus vapors and gases. And that may be falling into, in some environments, and this will stay into the standard lift category for liquid and maybe into the critical lift category because of vapors and gases. Because if that is punctured and we do have a release and we do have to evacuate certain part of the community, then most folks are going to be deciding that when it falls into that category, we're going to be writing a critical lift plan and make sure all of our homework and all of our data has been gathered, and we're going to perform exactly to the plan when those conditions arise. So this is the decision tree point that management groups will need to be going through, and this will, I believe, will end up in front of us in a year and a half as some of the documents come forward. Proximity hazards, of course, we all know about the prohibited zone with power lines, and this also proximity hazards talks about process lines, tanks, and a work product that can, as we just discussed, gases and vapors getting out into the atmosphere and environment. So it's not only for electrical shock, but proximity hazards have to do with things beyond electricity that can get out and get people hurt as well. So where does that fall in your organization? Sometimes we work with folks that say, heck, that's a standard lift for us every day of the week for this kind of lift. Some folks that scares the living hoo-ah out of them, and it's a critical lift no matter what else is playing. Also proximity hazards that we talked about, and radio frequency, electrical discharge and shock and those things. We just covered that. So let's move on to complexity of lift activity. And this again, this is the decision tree. So folks will be potentially looking at these as bullet points and deciding we got one of those, we got one of these, we got one of these. All of a sudden, it's into now critical lift planning. So that's the listing we're really looking at. And in this case, for complexity of activity, just the shape of the load, these are sort of intertwined. Probably no single item here is going to immediately cause us to go to a critical lift plan over a standard lift plan, but it's all about potential instability during the lift, which could be shape. And I'd kind of tie this thing to shape and sail area have a lot to do with that. I know Larry Shapiro's on our P30 committee, and he's done marvelous papers and presentations on wind loads on cranes and on suspended loads. There are, as the bigger the load gets, bigger sail area and the higher pounds per square foot of push ends up as a huge issue. I just worked with a client actually here in New York. They're on a 77-story building and looking to try to fly panels off and have opted to take those panels up to the top of the building and then dismantle them and take off all the sail except for the steel beams and then lower them back down. So they won't be flying these big sails and try to skinny them down right down to street level. They'll take the sail area away. So they've opted to call that a critical lift plan when they're moving it up, and then it'll be a standard lift plan when they take those beams down because they'll be in a very minimized sail area. So each one of those is going to get into how do we approach this work activity and how is this going to affect and what's our potential for survivability and potential for injury. The load integrity is also another one for complexity of lift. We know that loads come in sometimes and they're crated. They may have a steel frame base, and they could be in the 100-ton range, but they're on a big skid or flat rack, and how those get rigged up certainly can cause issues. In this case, certainly we'd be looking at likely a spreader frame up above to be able to rig and to be able to come down off that spreader frame to be able to not crush or do side load damage to that and potentially crush the item that's inside of it. So load integrity, we may have very specific lifting points that are going to maintain the integrity of the load and not do damage because we've misrigged it or we've used a different rigging method that's going to cause injury or damage to that equipment. Obviously, center of gravity to lift points. I hope Jim Meehan is on line with us. Jim is owner of liftplanner.net. It's a great website. I'd encourage you to go take a look at it. Jim, I know that Jim was involved in a project a few years ago just about lifting a statue up off of a state capitol, and I'll tell you, it's really difficult when you start in with a high center of gravity load, and this thing is up, and there's almost nowhere to rig that except at the base. And so to get the rigging up and to maintain, of course, a high center of gravity up here and to try to keep that thing from being tippy or flipping over and doing all those things, they ended up creating 4 pick points and then girthing at various connection points, girthing their slings, and basically creating a basket from walls and base to be able to support it. But center of gravity, the pick points is huge for stability, always something to really consider. Where is the CG in its height in comparison to my pick point? Obviously, horizontal, left, right, north, south, east, west makes a big difference on sling loading, pick point loading, etc. But center of gravity and its height has a huge impact on survivability of that lift being successfully completed. And then, of course, we've got things that can go awry in a lift activity. And that's another consideration point is there anything that can move, shift, or readjust itself while we're lifting or moving it? So we know we have loads. Sometimes we're called on to move tanks with some liquid in them. We just picked up even a small one the other day, probably about 6 tons, and it probably had 300 gallons in it. But it did make some change in the center of gravity as that just reorganized itself at one end. We were really well rigged all the way through, but out of 6 tons, 300 gallons isn't much reaction, but it will certainly move that center of gravity. And if you can't evacuate that, it can cause some problems with it. So anticipation is really the secret answer there. Draining anything out or securing anything that might move in advance could actually take it out of the critical lift category, move it back into a standard lift category, if we can say, okay, that's going to go away because of these prior actions. Let's take a look at the next one, complexity of lift. And are we using complex load handling systems or methods? In some cases, they may be new machinery, things we haven't used quite often, or it's new technology in our work site. And it may be, of course, later on we'll see multiple LHEs. But it may be a transfer that we transfer load from a gantry system to a mobile crane. And that can be present all kinds of issues by where's the center of gravity, how's it supported, how are we taking care of the horizontal movement. So these all play a large role, and typically in that case, in those situations, we will likely get into the critical lift family and not anywhere near the standard lift effort that some folks might apply. If the load handling activity can encounter obstructions, that just means tight clearances, tight areas, and the load may just be skinny enough. And we've had loads going through with 1-inch clearance on the left side and right side. So it takes a lot of pre-anticipation with what any wind might be inside of a building. If we open a door at one end, open a door at the other end, we have a huge wind tunnel effect going on. Tag lines obviously have to be used in many cases. Could be a multiple overhead crane lift, and so clearances can be a huge issue. And in that case, what a critical lift plan will do for us is to drive us to plan and talk and make sure that we're able to discuss everything with all the members and all the operators so that everybody's on the same page. I think that's the best side benefit out of a critical lift plan that gets developed is that discussion by all the parties involved, and it's really, really important for the successful outcome. Let's take a look at the last one on our page here. If the load is to be manipulated or rotated and turned. You know, Zach, I got a good call the other day on load handling with 2 hooks on the same mobile crane, something that is done quite often. It might be. So in this case, we have a rooster assembly up here, and coming off a mobile crane down below and hydraulic outriggers, the whole works. So we're lifting off on the main block, and then we have rooster assembly, and we're lifting also off the headache ball. These are kinds of things that when these devices get down, we had to actually get a manufacturer's approval to do a pick and turn the other day. We rigged up to the center using a spreader bar to make sure that we didn't end up with contacting the sling edges against the load, and then we rigged up with the whip line with another spreader bar at the far end to make sure that this could also clear the top and clear the top as we started to make that pick and turn. So this entire unit was going to be taken from this orientation, then turned up, and finally turned up in a vertical orientation. To do that, we had to get the manufacturer's approval because we had to check the lift, double check the load handling requirements of the whip line based on the tailing operation, check the main hoist for the header operation, and then make sure we had clearance for all the slings, all the rigging, and to be able to upright that, and to get their approval to use 2 hooks at one time. It does take, in our case, takes manufacturer's approval to do that for that specific crane. You don't want to just start doing it at the drop of a hat. And I noticed in the B30.5, there is discussion right now about providing some guidance within that, and that may be a few years away, about doing 2 hook picks and provisions that might require LMI for both the whip line and the main hoist, or at will within the operator's cab. So just load turning is pretty complex, and it can get you in a bind pretty fast. I know that a number of folks we've done investigations for end up cutting the rigging because they didn't use spreader bars. Cutting slings as they make a rotation like that or a turn up, and all of a sudden the slings go around the edge of the load and cut the rigging, drop the load. So this is really a complex activity, and be something I'd really encourage folks. Hey, don't just go out to the backyard out there and just sort of say, well, hold my beer and watch this. This is something we really want to take precautions on. And anytime we're talking about load turning or rotating, manipulating the load, it may easily go from what some folks might consider standard to go into that critical lift category. And then finally, with the complexity of load handling activities is the multiple LHEs, as we described before. This is kind of a new category that a number of us in the industry have talked about. It's not that our folks aren't qualified. You know, we have qualified riggers, signal persons, operators, the whole works, and serving in most all of those roles, qualified lift director. But it may be getting down to a situation that, you know, this event coming up has never been done, and that should already send up a bit of a flag for consideration by management groups, or it's something that it was done, we did it 12 years ago, and we have nobody left in our facility that was around and actively involved in that when we did it 12 years ago. So to say that we have, it's a unique item, yes, it's infrequently performed, and there is some evaluation. You want to decide, do we actually have the skills, the knowledge, and experience of the personnel involved in this to be able to accomplish that? And that's where a good lift planning activity will really knock down a lot of those things, because they do understand center of gravity, load manipulation, LHE capacity, all those things start to play. If they just haven't done it for a long time or never been done, doesn't mean it can't be done. You just have to slow the circus down a little bit, and let's get our planning in place and do it right with the equipment that we have. It may also be a place that you hire a contractor to come in, or an outside lift director that's done that kind of work before, and so an outside lift director may be able to come in and provide some good assistance. And there are a number of those types of groups out there. I know Kevin O'Neill with Seifert Associates works with us on the P30 group. There are Steve Sparrow. There's a number of folks around the industry that are heavily involved. And folks like Jim Yates at Barnhart Crane and Rigging, they'll come in and do some advisory group and consultation with folks. So there's a lot of ways to skin that cat, and sometimes this particular category might be with some assistance with some other folks. Let's take a look then at impact of environmental condition. So here's it, and remember, all that we're really doing is working down this list, a decision tree. Do I go this way to decide standard lift, or do I go this way to decide critical lift? And that's what we're really talking about. Wind, you may know your wind limitations, certainly on wind farm construction for turbines. They'll get into sometimes approved higher capacity or higher wind speeds. And, you know, most of the time it's 20, and they may have provisions to go to 33 miles per hour or the equivalent. It is, and so in some job sites, because of the approval by manufacturer, they'll be allowed to go up to some higher value, but only when a critical lift plan has been put in place. So those are considerations. You want to stick with your existing wind restrictions for your LHE, and only they would only be negotiated to go higher only with approval by the manufacturer. So this isn't anything to mess around with. We know wind is a big deal, and it can really have a detrimental impact on us. So it's something to take in deep consideration. I know that there are probably a dozen folks that we rub shoulders with in the industry that do ground bearing pressure evaluations. And Zach, I think we had a question on ground bearing pressure in the initial sign up for this webinar. This isn't something we want to just go out and stomp our foot on the ground and say yes or no to. We're going to often need geotech support and end up doing some serious evaluations of the area, and we'll need to have some professional service groups come out potentially and do some evaluations for us. I'm working with an outfit, a good client down in Louisiana right now. They would like to restrict all their lifting activities to 2,500 pounds per square foot. And it can be difficult. It creates a lot of matting, a lot of crane outrigger blocking and matting and spreading that load out, but they work in some swampy conditions or marginal conditions. So sometimes an entire site will have a restriction as to their maximum pounds per square foot, and we will have to live within those. And that may be for standard lift activity to go any to achieve any lifts that are going to impose greater than that given value. We may have to we'll certainly have to go into a lift plan and get an engineer's approval to do that. You know, temperature has some big impact on our lifting conditions. Moving surfaces, this typically is water. So we're lifting on and off water on barge cranes to dock, on dock cranes to water, tide issues from barge to barge, moving vessel, floating vessel to floating vessel. All those things can get involved in some environments. Some folks work with that as a standard lift. In many cases, other folks that are a little unusual for them want to move into this critical lift category. Visibility is always an issue, and precipitation. We won't spend much time on that. Those are pretty obvious, but radio communications is key and critical. We know that when we get a 300-foot tower crane up here, and he can't see anything when he's lifting a load up from street level up to the building level, he may easily have an entire fog bank below him that he's got. Everybody's out of sight, and everything, it's all blocked out. So a lot of times visibility is going to be some issue in many cases, and that's where we're going to lean on the technology for drum counters, rope counters, trolley measurement, hoisting speeds. All those things have come into play. So the operator and the lead rigger and lift director want to be tight in communication with how we're approaching those load handling activities. This sounds kind of funny, but potential to exceed LHE. Well, when would we ever do that? Well, you know, sometimes it happens. I've told a lot of clients. We had a really good client over in Saudi working, and as we started lift planning discussions with them on certain tasks and activities, to do installation is almost the simplest of all work. And we pick up a 10-ton load, pick it up, go over and set it down, no big problem. And we understand radius or distances we've got to travel that load, et cetera. But boy, I'll tell you, when we get into this extraction and removal of equipment, sometimes folks are ending up, if they can't use wedges or jack screws to get things broke free, that sometimes they're using the crane or a gantry system to actually separate that piece. So there's going to be likely a time when they're going to actually, above that load's actual dead weight, let's call it again 10 ton, they may be for an instant over here in the 12-ton range, and it is going to be a big deal for confirming, can we take that extra load for an instant while we break that thing free, because that may be right at the end or limit of that LHE. So when we start extracting things and removing things from service, it's quite likely to get into some small overload, and if we're already at 100%, we could be in big trouble. We can really do some damage to equipment and have some catastrophic failures or catastrophic events as a result. So it is a particular category, and you really want to pay attention to it, and it is a consideration point that you want to take and keep to heart, because it is a place to easily get into overload of equipment. We know that abrupt starts and stop acceleration. We worked in Texas this summer down in an area that they were sinking a 200-foot shaft, and they were removing 35-ton buckets of muck. And they were doing a tunneling system, so hoisting all at one time, and then sending those buckets back down. And really, they're able to work at 400 feet per minute on their hoist. And that abrupt start and stop, if that ever happened, could do a lot of damage to that crane, number one, but also the hoist system, boom hoist, main hoist. Everything starts to take a shot, and you really want to, that's if here, I guess, God love everybody here, but it's cowboy operators are, really, if the guy gets up in the crane, he's got big spurs on and goes yee-haw, you probably want to go pick another operator. Things can really happen fast, and it's not about speed. It's about condition of your equipment and taking care of the people that are working with you. And let's not get too out of control here. We just slow and steady wins the race. And some things we share with some of our clients is that out of a complete crane and rigging job, it's about 90% of the time are we spent making the decisions, determining all the information, getting the crane organized, getting the rigging attached, and doing all those things. And then about 10% of the time are we actually suspended. So if you take that kind of approach, 90% of the time we're spending minutes, if not an hour, to get everything ready, and then 10% of that time is spent actually hoisting or lowering that load. This is no time to be fast. This is absolutely the time to go slow for this 10%, because that's when this acceleration, shock loading, dynamic loading, everything starts to happen pretty badly and things get out of control. So we've already burned up a lot of time over here in this preparation, and there's no reason to try to gain all that back just while we're suspending everything. So slow and steady wins the race. I can't tell you how often we get called for accident investigation when somebody really wants to just get too happy, too fast, too quick, and all of a sudden they paid a really severe price for it. Certainly in that same type work, we can have excessive line pull. You all know what that leads to, and we're going to be overloading a lot of equipment in a hurry. So slow is the way to go. Potential to exceed LHE is, and also we want to double check on brake settings and clutches. Are they able to take all the things we're asking them? Accuracy, the weight estimation, that's going to keep that LHE standing up, not falling down. What is the equipment history and condition? We all know that cranes ought to pass their annual physical and all the monthlies and dailies that take place, but we do know we do have some older equipment in place, and there may be places, locations, we don't want to be operating that equipment because it may be high cycle or duty cycle activities. So serious decisions, and if we're going to use a specific crane or LHE for specific work, again, in this case, based on the value of the load, where it's got to go, the dangers and risks to personnel, all of a sudden it changes from standard lift and it moves over here to the critical lift family, because even something like this, age of equipment or conditions, adverse site conditions, which we discussed briefly, and then load shift during handling, we want to minimize those certainly, and that also can lead to LHE capacity challenges. Let's go to the last one here under this, weight distribution. And that's transferring load from one LHE to another, and or as it's lifted or tilted. Sometimes tilting the load can certainly change the center of gravity's position in its relationship to each LHE, and can shorten it up on one side or lengthen on the other. So those are all big issues. And then moving, and we talked about large mounted cranes and things that are affected by current and tides and buoyancy. So, and picking loads up that are in the water and get them out of the water, we've got to make the transition for 63 pounds per gallon and weight per cubic foot, or 63 pounds a cubic foot, and what that's going to do to us for lifting that load out of water, and once the brake's clear, what that has for an effect on the load handling equipment. Zach, I think we had another question, a polling question, I think, on percent of lift as an issue for people to establish a critical lift, something in that neighborhood.
Yep, I just put it on the screen. Does your company utilize a designated percent of LHE capacity to initiate a critical lift plan? So it looks like we're getting a lot of responses so far. You might want to take one of these questions really quick. I think regarding crane setup, the one was from Scott Ingham of Fluor, asking about how do you do ground bearing calculations by hand? And the other one you were referring to, I think, is let's see. Oh, any discussion on maximum outrigger loading, would be essential. But looks like we got about 60%. I'm going to keep it open for another minute if you want to chat about any of those.
Okay, sure. I have asked a number of civil engineering groups on ground bearing pressure questions on doing field evaluations, and I'll tell you, it really gets sticky. Without proper equipment, and we've got to have the proper equipment. I know folks can say, well, I can free-fall a bowling ball on the ground and I can measure indentation. Well, that may be one thing, but it's also about ground mapping and doing underground subsurface areas with faults, cracks, voids, all those things. So we want to. That's something that you can't just determine from doing a drop test or a hammer test, anything else on, or tire impression test as you drive a piece of equipment across ground. It really is going to take some a civil group to decide. In most of the, I got to tell you, I haven't found any way to really do competent ground-bearing pressure evaluations just with crane operators, riggers, and site folks without using geotechnical assistance from professional service groups. So only thing I can tell you is I'd really be wrapping my arms around these folks and getting them deeply involved in it. I don't have an easy answer for you because there just isn't. I would encourage you to start really getting in good discussion with a number of geotech groups and finding out what they use for practices, procedures, and equipment. But typically, it's one of those that would probably be best left to the experts. And Zach, I think you had another question on.
Before we do that, Mike, let me close out this poll so they can see your screen again. But
okay.
just so you know, there is 76 to 90%. That's the percentage capacity that 50% of the group actually uses to initiate a critical lift plan.
Okay.
Which is
all right.
A good number. 8% over 90% capacity. 25% do not have a process like this. So I'm going to hide these results, and your screen is now visible again.
Okay. Thanks for those results, everybody. And you know, it's really interesting. We polled our P30 lift planning members about a week and a half ago. And actually, we found about half of them use a percentage within their organization, and somewhere in that 75% range. And part of that came from an old OSHA definition of what a critical lift might be. And but sometimes it's corporations decide that, and certainly in some organizations run 90% and so on. But we'll kind of we'll talk through that in future webinars. But it is where your comfort level is. It may actually be based on some of the age of your equipment and so on, or the soil surface and those kinds of things that may be sitting on, and ability for leveling the unit. All those things start to play a role in it. So it's not a bad number. I mean, it's a good target point, and it's a good thing to put in your hip pocket. And it just needs to melt in with all of the other. It's tied with all of our other consideration points. So if you can see the screen, I talked about ground-bearing pressure and using geotechnical services. Really, that's the only smart way I know to go about it. I just field evaluation by let's say, I'm going to just say non-qualified personnel and/or personnel without using time-proven equipment. We're going to get into a bind here in doing some of these thumper tests. And I would really be cautioning against that, particularly because of the underground potential that we have in some of those areas. That the mapping systems that are out and available today really huge help in identifying subsurface voids, faults, and vaults. So I'd really be using professional services. I would not really endorse or encourage anybody to just decide to go out and stomp on the ground and decide, well, that'll handle 2,000 PSF. So be really careful with that. There was a question, Zach, about matting or outrigger bearing pressure.
Yeah, Kerry Coburg from DICA, he asked, any discussion on maximum outrigger loads would be interesting.
Yeah, you know, that's a good question. We did get in a conversation, though. What you want to do is, there are a number of folks that that are in the, and that is manufactures outrigger pads, and it isn't. A lot of folks build old 4x4 through bolted, and let me kind of just do this. And so they got plywood tops and bottoms. It might be a 4x4 type construction, and on any given day, these might look like they could have say 3,000 pounds per square foot, and all of a sudden you throw one on the ground and it's all crumbling and it's all falling apart and doing ugly things, and all of a sudden we punch an outrigger right through it and bend all the bolts in it, and you know, that 3,000 PSF goes right out the window. So you want to be really careful about identifying or giving an absolute value to some of the blocking that gets created by 4x4, 6x6s through bolted, because you really want to, if that's done, you want to test those and confirm those values and have an engineer really do some calculations on compression values to make sure that they're going to be satisfied and suitable for that work. I'm very impressed with the synthetic outrigger pads that are being produced today, and we have a number of them, and we're looking at purchasing an additional, but they come in all different sizes and shapes. These synthetic ones will get into very high capacity and pretty good span, and they're stackable, they're fairly lightweight, and very dependable when it comes to having a repeatable compression value. So I would encourage you, and Dyke is one of those that manufactures those, and they've got some great units that are available, and might take a hard look at those. We've started to phase out a lot of our wood blocking outrigger pads and really gone to this entire synthetic arena because of the long-term dependability and low maintenance and lightweight, and it helps our people in the field from dragging big heavy mats around. So might be something to investigate. I hope that helps answer that. Let me get back, and we're just about done. I know this looks kind of funny to you as lift plan considerations, but it's definitely what can make or break an organization. And this, again, as we had discussed, well, at what point do we decide standard lift or critical lift? And this corporation may decide with the replacement time of X, if we don't get this replaced, if we drop this and we have a crash and burn and all of a sudden this thing's out of service, and if it takes 3 months to replace this, we're going to be paying a penalty of $4,000 a day or something because we're stopping a job. So that likely would go away from the standard lift category and immediately go to the critical lift category because the replacement time of the specific item about to be lifted or needed to be handled, it falls into extra attention, discussion, consideration, calculations, and engineering review potentially. So the replacement time is definitely a big ticket item, and I would think this is really your risk control, folks. We're going to get involved in this entire discussion about commercial impact on the organization that's actually handling the load. And it's not so much that even you can pay this off or shove this off onto a contractor and say, well, if they drop it, you know, it's their nickel. Well, that's as good as their insurance policy, but it still stops the job and your reputation is still on the line. So commercial impact, cost of replacing the load, and sometimes the load is irreplaceable, like it's a one-off and it's never going to be made again. That'll be a decision that might take that out of the standard lift category and over into critical lift. And then failure to comply with it could cause a shutdown of the work activity or disruption of general public. I know a lot of folks that do bridge replacement and bridge work, every time they're putting a bridge section over a major interstate, and typically it's going to be at night, and they're going to do all that deck setting, and all of those will be in that critical lift category because general public shutdown of a major highway and interstate costs you so many dollars per hour per day, and they just won't mess around with having Billy, Joey, and Bobby going out there and deciding, yeah, throw that across the highway and we'll be good to go. They're going to have significant details with an entire team behind them to decide that definitely will be out of our standard lift category and into critical lift category. Also, unique site requirements, and this falls into, it might be a nuclear plant, it could be a refinery. Corporate policy, worldwide corporate policy. I know that Shell, Bechtel, BP, a lot of folks have corporate policies, and they supersede almost everything that's happening at the local level. And so given their guidelines, it may just, and have nothing to do with OSHA, ASME, or the state, county, province, country. It's their corporate policy, and those decisions will define and generally drive folks almost always into a critical lift when there's a question versus a standard lift. We obviously have to attend to these standard regulations, and then potential for interruption with infrastructure. This this typically will drive us to the critical lift family as well. So there's part of our decision tree starts to get answered. And repetitive lifting, as we stated earlier in our first frame there, that we can have repetitive lifting in standard lifts and critical lifts. And this is what our current thinking is nationally on this, is that what falls into place and what starts to happen are these three things: complacency, fatigue, and distraction. And because of that, and any of those can happen in either one of these categories, standard lifts or critical lifts. And we're going to want to put something into place that helps take away the risk related to complacency and certainly fatigue for folks swapping operators in and out, swapping riggers in and out on a long-term repetitive lift activity and or distraction. We know what all those are about. So repetitive lifts can enter into either category, but because of the length of the project, length of the work activity, it could be a 16-hour pouring job with concrete or 24-hour, 36-hour pouring job. They may call it a standard lift, but they're going to write a specific requirement that they'll have change out of either personnel within a specific clock cycle, et cetera, and to make sure that they're maintaining a fresh look. Everybody's on their toes, everybody's doing their job, and they're trying to minimize and lower the risk at all times and getting everything dealt with and dialed down to minimum risk, safest operation, most efficient way to do it. All right, let's take a look. Oh, this is something kind of unique that one of our customers requested. I was down in California, and this is at a chemical plant. They make fertilizer. And so they said, you know, can you help us? These are the things that mean the most to us, and these are what we run into in our fence, in our gate, and this is our playground. These are conditions, and we'd like to have a look. And so I, instead of detailing out a bullet list, I ended up creating for them a scorecard. I know that's probably a little difficult for you to see on your screen, but this is an Excel document. So there are 24 items that we listed out for them. I had a counseling session with about 10 of them in a room, and we went down through and created a list of 24 items that in some cases they're a no-brainer, they're a critical lift. In other cases, well, when you have these combination of things, it gets to be a bigger issue and we're going to need to tackle it. So there are 24 items here, and certainly the list can grow. You'll notice that there's this whole center section that talks about value of the load right in here. And each one has a point score system, and notice that the lower phrase right down here, when it gets to be 5 points or more in this bottom box, then we go to a CLP, a critical lift plan. So you'll notice that item 8, I know it sounds kind of screwy, but for their environment, release of accidental release of sulfuric acid would count only for a 1. For them, that's a liquid. It comes to the ground. There's risk inherent with their operation, their employees, their equipment, and so on, but they accept that risk every day they come to work. That's not a big deal for them. But if you tie that number 1 risk item with a load that's going to must be rigged in a choker or basket hitch, which means we're not directly connecting to the load, and then we add that to personnel that are in significant hazard and location to that, well, all of a sudden now we take that number 1, number 2, and number 2, and that becomes a 5-point lift, and that all of a sudden we will do a critical lift plan for that. So this is what they asked and came out of our total discussion. You'll notice, as some of you have indicated in the poll that was taken, item 4 right here, in this case particularly, multiple crane lift, and either to be used at greater than 75%, that's an automatic 5. On theirs, for a single crane lift, you'll notice that item 2 right here, a single crane lift at greater than 85%, then gives them a 3 points, and that's a pretty big push. Anything else that goes with that just about will push it into a 5-point final line item. So this is how they use, this is just a little load lift determination scorecard, and it's Excel for them, and they decided that this is how we're going to make our decisions, so that if safety department looks at it, the crane and rigging department, site management, lift director, everybody that looks at it they can come up with a pretty quick determination. How close and quick do we get to a 5? If so, we're going to go to a CLP. So it's just a unique item for one site. Doesn't work for everybody. Just sort of, and a lot of folks have something like this, but it may not be in a specific scoring or point system. But it sort of gets you there and gets you to discussing and talking about some of the real risks related to that. Zach, I think we have another poll coming up for our last one, and we're just about done.
Yep, launching it now. It says, does your company use some form of a critical lift plan scorecard?
Oh, good, okay.
So everyone, the poll's open. We'll keep this one open pretty short, so make sure you get your answers in there. Looks like everyone's answering it pretty quick. Okay, I'm going to close it here in about 5 seconds. All right, so the results, overwhelmingly about 80% have said no, they don't use a scorecard. About a quarter, almost a quarter say they do. So I'll hide those results.
All right.
Have the screen again.
Okay, excellent. All right, well, here's an idea. I mean, there's just one approach. It can be dollar value, and really this is a culmination of a lot of things we've talked about today, is risk to general public, risk to personnel, overloading, LHE, or potential high percentage of lift, folks in the fall zone, pressurized materials that can be released to the general public. All those kinds of things can turn into a CLP. So it's just an idea and something you might consider downstream or see how it works for your organization. Okay, well, I'd like to open this up, Zach, and for questions. And I'm not sure about all the answers, but I'll entertain all the questions I can and do our very best. And if we need to get back to you on something, we'll do that. So let's go forward with a few questions and see what we can do with them.
Yeah, one of the, let's see, a question came in from Technical Oil Field Supplies. How important are ground leveling considerations in heavy lifts?
Okay, yeah. Ground leveling is every LHE. I'm gonna kind of step outside the box here and say every LHE, whether it's mobile cranes, tower cranes, telescopic hydraulic gantry systems, work on extreme requirements for ground leveling and ground compaction and load bearing capability. Just about everything all the way down is critical for the ground to be within 1% grade, or certainly less than that in some cases. And in some cases for mobile cranes, we're looking at 1 degree out of level. You know, can be required in some circumstances. So it is a huge issue, and being out of level is quickly. If a lot of you have taken a lot of mobile crane courses, of course, and you know the old setting up a mobile crane a bit on an incline like this, and then of course the hoist line is dropping down like this, and all of a sudden the side loading of the boom is huge, and you can lose 50 to 70% of the capacity very quickly by being out of level, just uphill, downhill. It really reacts fast, and it really can do some damage. We're picking a load uphill, and as we swing it around downhill, just swing the crane right around, and all of a sudden the load's at a further radius. And I mean, just things happen very fast. And so being out of level is a huge issue and can be deadly, you know, in most cases. So make sure that we've got the machine level and everything. It may take dozer work. Ground compaction may take some 5-inch, 3-inch, 1.25 minus, 5/8 minus, and a lot of compaction work to help build that foundation and get it level. So that's, I think every manufacturer's document will tell you that our equipment is intended and has been tested on level ground, and that's how you should operate it. Good question. Let's go to the next one.
Okay, Pam from Kimberly Clark asked about critical lift definitions for inside a manufacturing facility instead of the construction side. Okay,
good question, and I would like to pull up. So all the same considerations, and I hope we've covered those inside. Those weren't really restricted to the outside load handling. So all of this morning's items that we covered really do address inside handling as well as outside, but I did preload a little bit for you. I'd like to take a look. Pam, here's a critical lift document that we use in our consulting activities and field services and so on, as well as sometimes of our load handling training. So here's a critical lift plan for overhead cranes. This is really the first page of 4 pages, but you'll notice that this sort of a left and right layout to it. Load is here, crane is here, crane hook. Which hook are we going to use, the big hook on the bridge crane or small hook? Over in the right-hand column, considerations could be multiple cranes. And then pre-lift checklist is all a big part of that. And as we go down the front sheet here, of course, we have the rigging considerations and the operating area obstructions and others. And I'm going to take you to page 2 because we have an entire fill in the blank and kind of draw your own load path. And this may be that the bridge is here, the trolley starts here, and the load is underneath. And so we need to do a full drawing within the site or facility. So we've got man doors in here. We've got to take that load from this point over an obstruction and then work it down through the bay. And so we'll bridge, trolley, and bridge to get it down through there. So it's a load travel path. Where do we want our people stationed? And we want somebody stationed by that door because it may be a high consequence lift or critical lift or something in between. Where is our signal person going to be? Question mark. Where's the operator going to be? And so we'll draw that right on the sketch. And so personnel placement, load path, and we can schematic that right out. I'm just going quickly here. What's the load look like, load schematic, and rigging method? So we want to double check is our rigging plan. So we'll have a quick kind of, you can even do a photograph and lay that on top and do some sketching over it and confirm your load, and it may be 18 tons, and we may have some known distances with it, and of course then that we'll have some calculation to identify what's the minimum rigging based on tension, is there a rigging shackle, and controlling with tag lines and so on. So this load schematic and rigging method will be detailed out, and it will talk about X number of slings, shackles, and this can all get transferred to the front side of this document, right over here to the front bottom portion where we're gathering all of our data right in here. So you do a load and rigging schematic page, and then on the last page is pretty important because this is actually where the discussion with the crew and the teams come out. So item 1, 2, 3, 4, 5, and then we get down to we want to barricade all the area. We've already alerted safety or security to help make sure we don't have any incoming traffic. We want to position the crane over the load center of gravity, attach the rigging, and it may be that we end up with detailing who's assigned and who's responsible to do that, and it may be different folks that are assigned those tasks. So it's a load handling sequence and procedures. So it really goes down through, and this entire page is dedicated to, we're going to do this in 12 steps, and this is how we're going to do it. Anybody see it? And we might do a dry run to help make sure that this is all doable. So there's a lot of different lift plans. Certainly these can be typed out, but in the field they may be handwritten in some cases, and fill in the blank and make sure we don't miss any of the boxes necessary to achieve that appropriately. So I hope that gives you some comfort that not only can we do this, this would be a standard one for mobile cranes, and we've always seen a lot of those, but we can do that for overhead cranes. And then we've even got one for winching and pulling a load sideways. So here's a load winching plan for blocks. Notice we got rigging blocks over here, and we need to draw out the block position on the where it's connecting. Boilermakers would use this type of system, and pipe fitters all the time for using winches. What's the load description, and what size winches are we using? All the capacities, block requirements, all the load data is here, all the winch data is here. How many blocks are we using? Multi-part system, what's the mechanical advantage, and get down to what's our loading to columns and beams and so on. So the same format for load winching, detail the rigging system, load schematic and rigging method, and personnel and assignments. It's a 4-page document just for load winching, going sideways with the load. So it's kind of regardless, and as I started earlier today on this presentation, it's really regardless of the LHE, we still got to move that load from one area to another, and that we can substitute those forms I just showed you for overhead cranes, mobile cranes, and load winching can be substituted for with strand jacks, and it can be substituted for telescopic hydraulic gantry systems. And I mean, it's just really you pick the piece of equipment, and that lift plane will work with that piece of equipment. Great question, and thank you for that. What's the next one?
There's a question from Mike from Disney, but before we jump into that, I want to do one more poll question, if that's okay. While we have, one's going to be hopping off here in about 5 to 10 minutes, I suppose. But everyone, we're just looking for future webinar subjects. We've gotten a lot of feedback. Actually, for instance, this subject was requested months ago. So if you have any feedback for any future subjects you'd like to have or view, we'd really appreciate it. We're getting a lot of feedback here. So options, I mean, there's obviously more options than just these 5, but just want to see what the current populace would like to see in the future. So I don't want to keep this open too long. I'm just going to do another 5 seconds. And the question from Mike from Disney is, when is a written plan required, and is there a standard form for a lift plan provided by ASME? So maybe you can start answering that, and I'll close off this to go back.
Sure. Okay. All right. Great question. And the gentleman's name from Disney again is Mike?
Mike as well.
Okay. Great question, and thank you for that. Written plan, and most folks are going to get down to, and there's kind of we're not settled on the facts yet, but I think that we're looking for standard lifts, verbal or written, and I think we'll probably get to a point that we will be endorsing the idea that critical lifts will likely be written recommendation and not verbal category. And based on the selection criteria that I just went through just a little bit ago, which will drive us to doing a standard lift, which means we can verbally determine all the information we need and we're able to produce it without producing a document. That can be done verbally. Otherwise, you can do a written plan, certainly for a standard lift. Many organizations don't allow any lifting without a lift document of some type. I know that a couple of our members on P30, that's the standing policy within their corporation. So in their case, they don't allow any of this. It's got to be written for everything. So it's up to your organization and your risk level, and by management decision with the lift director and operators and riggers collectively, can we do that with verbal? And a lot of folks do, obviously. Verbal is done quite a bit. So, but really it's kind of restricted and restrained to the standard lifting category. Zach, there was a second part to that question.
Yeah, it was.
Oh, it's ASME is going to come up with a plan, right?
Yes.
Okay, great. That's a great question. At the moment, I will say that where our current thinking is, and within P30, it is currently it is a Chapter 0 is definitions and scope and definitions. Chapter 1 is the sort of the decision tree. And this is our current thinking. This may change downstream here. Chapter 2 is roles and responsibilities of personnel. Chapter 3 is standard lifts. Chapter 4 is critical lifts. And then we have an appendix. It's kind of a non-mandatory appendix that we're considering right now. And if you would like, and I don't know if we can do a poll on this, Zach, but if you would like to run a poll maybe in the future or now, but we are considering putting in like a 1 to 2 page critical lift plan example in that non-mandatory document, and something that may approach a 10-plus page CLP as an example that folks can look at to get an idea. If we're going to develop CLPs in our company, does anybody have something we could use as sort of not a boilerplate, but as an example or an exemplar? So it is, we are considering within this ASME P30 to put in a non-mandatory appendix that will have some critical lift plan document examples in it for you. So, yeah, the movement is there, and yes, I do think that we'll get some traction on it. And we'll also, once this document is finished, we're going to need to go out for public review as an ANSI requirement, and we'll also get the general public's evaluation of on all the chapters that are there, but also on the example for standard lift plan exemplars. So good question. Yeah, we're moving that way. We hope to have that in the P30 document. At the moment, everybody sort of shook hands on it, so we're hoping to make it happen. Good question.
Okay, Bob Berry from Sims Crane asks, is there anywhere to find a copy of the proposed P30 standard?
At the moment, that's a great question, Bob. Yeah, and thank you for that. At the moment, the ASME cannot release, they can't release anything that's a work in progress until we get all the way done with. At the moment, we're still in the writing stage. I will tell you this, in September, we're going to end up doing a review and comment ballot, which we're doing right now by the committee. October, we're going to do the first big official first ballot within the group. And I would say by the time we get to about February of 13, we'll have the public review stage. And at that point will be the time when everybody can take their shots at that document and be able to comment back to the committee, because at that point in time, this committee then will need to go back and determine if any of the items need to be readdressed. And of course, if we change anything, it'll have to go back through the balloting process again, and then it goes out for public review process again. So nothing really gets finished until we get done with the public review and satisfy all those comments and questions. So I'm sorry, I don't know what else to tell you, but I'm sorry, the P30 document cannot be released. It's against ASME requirements and rules and regulations and policies, and we can't, unfortunately, we can't release any of it until we get through all the voting and it's ready to go for public review. I wish it were different. It isn't, and I can't do much about it. I apologize. I'm the chairman, and I can't do a thing about it. So it is ASME policy that we have to live by. Good question.
All right. Richard Grabendam, for Heavy Lift Specialists, asks, what are your lift criteria to allow a 2 or 3 crane lift? For example, when erecting a pressure vessel with 2 main lift cranes and 1 tail crane.
Hi, Richard. It's nice to hear from you. I think you've been visiting us on almost every webinar that we have. So the question is the criteria for, let's put in two cranes up here on the head and 1 crane down here on the tailing. So we've got header up here and tailing on the same load. So, you know, and Richard, I think the key is most management groups would make a decision as to how they're going, to what percentage. And I think the biggest issue is what percentage would we set the percent of lift capacity for each of these 3 cranes. And I would have to say, without knowing anything else at this moment, most folks are going to limit the capacity of the cranes, just taking a shot in the dark right now. 75% of the capacity of the crane at its maximum working radius. This crane may actually have to crawl forward during that uprighting and heading and tailing process. No matter where this crane goes, generally, a lot of folks are in the 75% category, and I don't really disagree with that. I know in some shipyards, some of them will work to 90%, but it's almost production lifting for them with using portal whirly cranes, and they may run at a near 100% lift, but they've got the ability to roll with the load, and the load stays suspended under the main boom point. So on flat ground where the bases are not able to keep up with each other very well and limited. Of course, the 75%, it could be 60, could be 80, but 75 is a good target point. And if everybody's understanding, the biggest fear in the crane operator and lift director's mind is that the hoist lines stay plumb. They stay vertical. Because if we get this hoist line starts to get loaded out sideways or gets pulled away, we are likely going to have a catastrophic event in most all directions. So it's about keeping the hoist lines plumb and vertical so that they're able to maintain their capacity with a target capacity. And that 75 is a fairly good starting point, and arguments can be made either way to go up or down with that based on the machines, the operators, and the working environment and criteria. So if that answers your question, Richard, I'd say that'd be a place to start. Most certainly, I would add this one last comment, that load moment indicators are going to be the best friends, that we have a live readout in all three of the crane cabs. And I have worked on sites where they have a load moment indicator to be able to be read from a master box at the lift director's location so that he can immediately read out the load on crane 1, load on crane 2, load on crane 3, and he has a constant knowledge along with the operator of what their active load is. Because the loading instructions may be, you must work between 180 and 200 ton for each of these two cranes. And this one may be that you can work from 40 to 50 tons. Let's say the center of gravity may be up here and it's very light tailing. So the instructions are, if you start to pick up too fast or as we make the turn and you're experiencing some higher loads here, you've got to wait for your partner that's up here, and because you're going to pick up, he's going to drop off, overload your crane, pull him over with you. Or if you're not fast enough, you've got to keep up with 180 tons so that you're not overloading him. So the LMIs, load moment indicators and crane scales, go a long ways to help keeping everybody informed as to what values they should maintain, a range, a working range that they should keep up with. And once we start to peak out in either direction, we've got to stop all operations till we get everybody squared up. Good question, Richard. I sure appreciate it and sure look forward to having you with us on a future program. And Zach, any more questions?
Yeah, just a couple more, and just to get Richard back, and he just mentioned, thanks, I agree, when a detailed plan is drawn up and measures are used to monitor the load of each crane, we could allow up to 90%, was his opinion. So just want to let him close out with a thought there. And we have a question from Ed Dyna from MECO. Any suggestions when your load handling equipment is placed on ice?
We've got to create friction, and we may end up having to cut through the ice and create small piling that will help afford a stopping or movement best possible. We have to create the ability to stick that crane on that surface without horizontal movement. If the outriggers are down, pads are here, we've got to really work hard to make sure that crane doesn't go anywhere. The load on ice has something like a 0.01 coefficient of friction, and it is nasty. And anything gets somewhat, just slightly, if we're on a surface that's not perfectly level, it's a disaster. We've seen cranes slide on ice with the slightest of incline. So we've got to create the friction and stop the movement at all points. And it may be that sand, a small half-inch layer of sand is laid down, and then blocking, wood blocking or some high friction blocking is laid, and cranes are then laid on the crawler tracks or outriggers may be placed on top of that. But we've got to work hard, and it may be that they actually drive pins to restrict the movement of the outrigger pads or matting that's there into some hard surface. They may have to drill. I mean, they're going to have to keep everything from moving and keep that crane in one place. So they may be driving pins or drilling to try to restrict any side-to-side movement because it's going to cost the crane its life, and it's going to cost the load its life, and we're going to possibly cost some ground people their life if that crane starts to move off in any direction. Good question. Good question. Very tough environment. No doubt about it. Excellent. Any other questions?
Yeah, let's do two more. Brad Bassett from Hensel Phelps. Hey, Brad, how you doing? He asked what guidelines do you use when making a lift at or near an excavation with a mobile crane?
Okay. You know, that's a great question, and if we have what we would consider compacted soil, there are some rules of thumb for 3 times, so let's call this a 4-foot depth, is to be, it's a 3-to-1 type distance back for setting that crane up to be working. So at least 3 times the run for the 4 foot of height. That is something of a general industry approach, and that's really for compacted soils. If we're working on less than compacted soils, and with compacted soil, we're talking about near 100% compaction. And this particular area right here is fresh excavation. So if this excavation comes back and it's sloping ground and some of this is disturbed, we're really going to need to be at least a 3-to-1 back, and if not greater. It is really dangerous. The surge and side thrust of that soil is terrific. If you have to work in an uncompacted soil, backfill, and other conditions, and or closer than this 3-to-1 on compacted soil, we're really going to have to get soils engineering group involved, like Seifert and Associates, Hague Engineering. There's a ton of groups out there, but I'll tell you, they're worth their weight in gold, and it won't cost you very much. But once we get up to any of those conditions, there's no good rule of thumb because of the weight of the crane, the weight of the outriggers with the full load on the crane, because the bearing pressure is so huge right up at that front point. Realize we can take 80% of the combined crane and load on one outrigger right here on the corner. So crane plus load, 80% at one footprint. And we're pushing that soil, and if we're anywhere close to fresh soil that's been obviously backfill, any of those conditions or circumstances, we're really going to need soil analysts to really give us a heads up as to, do we have to go back and do compaction, get a bigger crane and move back further so you can reach a greater radius. But it's really very dangerous. It is, I will say that crane tip over, there's a lot of studies done, but certainly we know that the personnel, and I'll just share this with you, Brad, real quick. The personnel, it is electrocution. And with crane, so from the people side, we electrocute people, and that's the biggest issues with cranes. From the crane issue, it is loss of foundation. And that is, in our experience, that's the #1 cause of crane accidents right there. It's loss of foundation, crane goes over. And that soils condition you just broached the subject on is probably the biggest contributor to that. And I really want to encourage you, anytime we're working on any backfill area, obviously we're just going to have to keep pushing back and build up. And even building bigger mats isn't going to always solve it. So I hope I haven't danced around the subject with you. I've really tried to give you some good target points to go after. But it is, I would have to say that we're going to have to get engineering services if we get anything closer than that with uncompacted material. Good question, Brad. Thank you very much. I appreciate it.
Okay, we have time for probably one more, so let me pull that one up really quick. It's Colm from Alstom Power, or Alstom Wind, I'm sorry. And I just want to mention everybody that if you have any more questions or your question didn't get answered, it's really for the sake of time, but we'll be able to email you afterwards. There were some questions in the pre-webinar that were asked. And then on top of that, you're going to get an email of where to access this recording and the presentation. You're kind of going to be a part of this group of folks. There's been about 1,000 people that have gone through these webinars since we started in March, and there's a discussion board on the website that you can actually visit and discuss, continue the conversation, if you will, and that's where you access all the presentations as well. So be sure to check your emails on that, and let's get to the last question so we can get everyone on with their day. But it's, again, Colm from Alstom Wind. Should critical lifts taking place simultaneously on the same site included in the same lift plan?
Repeat that again. I'm sorry, Zach, we broke up just a little bit, please.
Yeah, should critical lifts taking place simultaneously be included on the same lift plan? And they're different lifts, but they're on the same site.
No, they would not. So if we're going to put up a wind turbine over here, and another one that's certainly in the far distance over here, and the fall area access, even the length of the boom can't even get close to each other. They're going to have site lift plan A, a lift plan B would be two separate lift plans, and they can be managed and operated simultaneously. I think the big issue would be if we, and from an ownership standpoint, from the property ownership, if we had two wind turbines being constructed within a close proximity of one another, and where parts, pieces, or the crane itself could fall and disrupt or contact the other one, then we would say no dual lifting. I mean, it's going to be, we're going to have to be very cautious about two major lifts simultaneously in the same footprint or zone that even by swinging or having some kind of incident could actually cost you both activities, both operations, both cranes, both towers. So if we can distinctly take a line between them and they can't reach, there's no way they can reach each other, then we would go with two separate lift plans, two separate lift teams, lift director and operator and riggers and ground crews. So if we have those conditions, then management likely would feel the risk is pretty low and very manageable in that case, but definitely not in this case. If they can reach each other, I think management would be just crazy to go forward and try to get too much done in the same footprint where the crane has that working radius, so where they can contact, even remotely possibly contact each other, even by accident. I think we cost ourselves a lot of money, and it will almost always result in fatalities. You just can't run far enough, fast enough. If we lose ground foundation and subsurface under this crane that's working right here, and we lose this crane and it goes over and knocks down the other, there's just steel and stuff flying everywhere. You can't get away fast enough, and you don't know which direction to run because you got two cranes coming from opposing directions. So no, we wouldn't want to have dual lifting in the same zone. We wouldn't want to do that. But when they're separated by acreage, footprint, and space, definitely they should be able to manage that, and they do that all the time on different sites. Great question. I appreciate it very much. Okay, Zach, I appreciate it. I really appreciate everybody participating and working with us. I look forward to being able to be with you in a future lift planning program and activities that go on about this downstream. If this is a subject of interest to you, I would say that I think, Zach, our next one is about B30 and a little bit about P30, but a lot of this emphasis will be about advancements and work activity and product that's been produced by the B30 group, and some of the updates to the documents. We'll only be able to cover with you what's been actually published, but you may not know about it, may not have a most recent document. So we'll be covering a lot of those things that are new on the in our libraries for B30 items. And there are now 30 volumes. A couple of them are still in development. So we have point 1 through point 28 that are approved. We have point 29, which is self-erecting tower cranes, and point 30, which is ropes. So those are under development, and we'll share a little more with those. Self-erecting tower cranes is 29, and that's just about ready to be public reviewed and released pretty soon. So we'll cover these 28, any new items with those, and a little bit more update on P30 that we can give you. We'd sure love to do that at that time on our next webinar. And Zach, what's the date on that? It's September, right?
Yep, it's September 7th. It's a Friday at 1 o'clock.
Okay. All right. Excellent. Well, thanks for letting me be here and be with you, and I look forward to our next time together. Zach, I'll let you close out, and thank you for helping narrate and facilitate this.
Oh, no problem. It was good to see everybody on today. Thank you for everyone that's been coming back so much. We really appreciate you coming on and working with you and learning with you. So again, just so you guys know, the presentation is now live on the website. You can get it by accessing iti.com/showcase and then clicking the View Past Recordings area. The video, the recording, the actual recording won't be up for a few hours. We got to download it and get through all the technology. But again, I'd encourage you all to join the forum there. You actually can log in through LinkedIn, and it's a webinar attendees forum to continue the discussion and continue to learn together and make the industry better. So great talking with all of you, and we'll catch up soon. Thank you.